In this section, we are going to talk about the actuators. An actuator is a component of a machine or a system that moves or controls the mechanisms of the system. Typically, an actuator requires a control signal and a source of energy. Once it gets the controlling signal, the actuator will convert the energy into a mechanical motion. The control system could be very simple, like a fixed mechanical or electronic system, or it could be more like software-based, a printer, driver, robot control system, or any other input such as a human or robotic. How actuators work? Basically, it starts with electric current, and then that electric power is converted into pressure, either air pressure or fluid-based pressure, and then it will convert into mechanical. So that is how the actuation work, especially in motor kind of industrial domain. There are few different actuator types we will be talking next. Before that, please pause this video and go ahead and watch this what is an actuator video clip to understand the context of actuation better. There are 5 key types of actuators widely used in conjunction with IoT: hydraulic, pneumatic, electrical, thermal and magnetic, and mechanical. Let us go through these actuator types in a little bit more detail in subsequent slides. Hydraulic actuators consist of cylinders or fluid motor that uses hydraulic power to facilitate the operation. Then the mechanical motion is converted into a linear, rotary, or oscillatory motion. Hydraulic actuators are typically used in large machineries or industrial manufacturing settings. To understand how the hydraulic actuators work, please go and watch the video that I have presented here. Pneumatic actuators are somewhat similar to hydraulic actuators. Instead of using liquid, pneumatic actuators use air, so the compressed air, or it could be vacuum to generate the pressure, which will convert into linear or rotary motion. Pneumatic actuators are typically used in control valves, water pipes. So if your IoT system is using some kind of valves, there's a likelihood you will end up using this kind of actuator, or controlling water systems, drainage systems. It is worth highlighting that pneumatic energy quickly responds to starting and stopping signals. So you can quickly stop or start. This is easier when we are using IoT to control, because you know that as soon as the signal receives, it will stop or start. This is not the case for hydraulic actuators. It takes some time, so you need to pre-calculate when to stop and start the motors, which uses hydraulic actuators. Pneumatic actuators enable large force to be produced from relatively small pressure changes. For example, pneumatic brakes can be very responsive for applying brakes when you're in your vehicles. I have put a video here about how the pneumatic actuator work. Please go and watch the video to better understand how the pneumatic actuators work. The next type of actuators are the electric actuators. So electric actuators are generally powered by a motor that converts electrical energy into mechanical torque. You will be using electrical motors or similar mechanisms within variety of different IoT applications, from farming to manufacturing, smart home, smart irrigation. There are a lot of places that you will end up with using electric actuation. So electric actuation considers as the cheapest, cleanest, and the speedy type of actuator. You can start very quickly. There are small, very small motors to very big motors. They are easy to integrate into any electronic system. So you will see a lot of motors or electronic actuators within IoT systems. To understand how the electric motors work better, please go and watch this video now. Thermal or magnetic actuators are the next type of actuators. They tend to be compact, lightweight, and economical with high power density. In the two figures presented here, you can see two different actuators. The first one is thermal actuator, where they have used this shape memory material, where this small material change its space based on the change of the temperature, and it helps to create a motion. On the bottom one, you can see a coil gun where it can shoot a bullet using the magnetic actuation. Both thermal and magnetic actuators are used in microelectronic domain to produce very small actuators inspired by the concepts. Mechanical actuators are the last type of actuator we are going to discuss in this section. A mechanical actuator converts rotary motion into a linear motion. It involves gears, rails, pulleys, chains, and other devices to operate. In these figures, you can see multiple different types of mechanical motors. They are widely used in vehicles, industrial control systems, HVAC systems within buildings, agricultural domain, quite a lot of domains. They use this kind of mechanical actuators to open the gates, close the gates, for irrigation or for sprinklers, and many other everyday situations.